Might have got a chance. There you go. There we go. Excellent. I'm second. How you doing?
Cindy just gave me the 840, so I think we have all three for this session. Oh, sorry.
they were just sticking them on the desktop. Netcentrics? Okay. It's a good thing you bought the thumb drive. USB access, right? Yeah, it works. It's outside later than mine. Oh, they just put it up there.
How'd you get this? Here we go. There we go. All right. Well, good morning. My name is Danny Lax. I'm Chief Scientist at Cole Engineering. I do R&D and business development and also work on programs as a software system engineer. I'm here today to talk about the CyberSAF simulator. This is in response to a problem statement that was issued out. The Army is looking for M&S tools in support of cyber mission planning, proficiency training, cyber situational understanding, and exercise support. There are 4 topics here, which I'm going to go through all 4 of those in the upcoming slides. And I printed out on the title there, the number I'm covering. So the first one here, why am I up here? What is the solution? Well, the solution is a combination of 2 things. And also, combining those 2 things, there's a shortfall. We'll talk about all that in this presentation. The first thing is CyberSAF. So CyberSAF is a configuration of another simulator called OneSAF. OneSAF is a government-owned open source simulation. Technically, it's a framework, not a simulator, but it is a simulator also. And from that framework, you can build other simulators like CyberSAF in this case. And what we did to OneSAF that was different than just vanilla OneSAF was we implemented some abilities to do cyber kinetic realization, the kinetic realization of cyber effects, and interoperability with what we call cyber action simulators, the ones where you actually go and hack and stuff. So in the cyber simulator, you would actually hack something, and then if they get into a system, that would be reflected in OneSAF or CyberSAF, and then that would have some sort of effect in the battlefield. That's the concept. And I'll get into that some more. That's item number 1. Item number 2 is, in a separate domain here, we also developed a course of action analysis capability inside of CIDAware. CIDAware is the COEV3 mission command system for the Army, supposedly getting fielded in early 2019, mid-2019, something like that. And it's politically charged, but it's supposed to replace, augment CPOF, Geeks, MCS, ASAS. That's CIDAware. So one capability of CIDAware is that it has an open architecture. You could actually extend it and add stuff to it. So we added 2 different simulators. The MTWAS is a Marine Corps simulator, and also OneSAF as a simulator in the back end. The idea is you make your plans as a commander in CIDAware, just like you normally would do in a mission. But the only difference is you'd hit a simulate this now button to develop some course of action analysis. Our metric is by the time you get a cup of coffee, you come back and you have some sort of meaningful results back. And again, I'll get into all that when we move on here. So first we'll talk about CyberSAF. In our opinion of CyberSAF, it's great to do the cyber domain modeling in various simulators, but you got to have that cyber effects capability there to really get the full picture. Because if you just hack in a box, and that's, don't get me wrong, it's extremely great skill to have, but what is the effect of that? What happens if that box is destroyed by the kinetic activities? What do? You need to coordinate these things. So that's kind of the genesis of CyberSAF, is to help fuse cyber into the real world. So in CyberSAF, we implemented essentially what we call signals to do. You could basically take control of a UAV, and you could defend it also. You could watch video feeds. You can control SCADA devices inside of OneSAF. And we implemented the ability to do street lights and generators and the cameras. So that's one capability. The second capability is we had to build a gateway to allow these cyber action simulators to talk to us, to tell us, hey, okay, the lights are off, click the switch. And that's essentially what this tool does. And you can use it with another simulator, or multiple simulators for that matter, or you could use it standalone and use it as like a measle inject tool. So you have either capability with that tool. So here's some screenshots of what CyberSAF looks like. If you look on the bottom right, this particular scenario is a Special Forces hostage rescue. It's fictitious. But the idea is that there's a hostage in the middle of this town here, and it's like a convention center, actually. And the OPFOR is there, guarding that hostage. And the idea is to insert Special Forces in, get the camera feeds, figure out what room they're in, try to go under the cover of night, so cut out the city lights. When you get to the building, surprise, there's a generator. They got to cut out those lights. And then they got to make sure they have the right room and rescue the hostage. So it's a pretty involved scenario, and it's designed, if any cyber element fails, the mission is a failure. So yeah, it starts out kind of looking like the bottom right, those little yellow cloud things. Those are unknown people. We don't know what they are yet. So on the one above that with the blue circles, we fly the UAV around, and to try to figure out who's out there in the streets, potential threat. And it's up to the cyber operators to defend that UAV. And then the game executes. The middle picture there with the I don't have a mouse, but that's the gateway I was talking about, and it shows the various feeds going on it, whatever. And normally it's hidden from view, but in this case we want to show it because we're talking about it. But essentially we created 3 states for all these cyber things. We kept it pretty simple. Either whatever the device is, it's enabled and working normally, or by cyber action it's disabled and off, or by cyber action it's compromised and perhaps somebody doesn't even know that it's compromised. And then the picture above it there, those are the camera feeds. So inside that building, we replace camera entities, essentially. And it takes that 2D picture and makes it a 3D picture, and that's live. And you can see people moving around and stuff like that. And that actually gets fed to a web browser. So it looks just like a webcam feed. And then on the left there is kind of the end of the scenario where they clear the building and rescue the hostage. So now back to the course of action analysis. We developed this capability. It's called McSAF, is what we call it, and that's CyberSAF combined with OneSAF. And we think, in our opinion, that CyberSAF is a great platform to realize the CyberSU capability because of its open architecture. CyberSAF, looking at here, it'll support the MDMP process. Because you could make realistic scenarios that someone would actually execute in the real world here. So here's some screenshots of what's going on there. So on the top left here is actually a picture of CyberSAF and the CyberSAF plan. And then this is normally, if you see on the bottom, it says the user never sees the simulation. You normally wouldn't see this, but of course I have to show it for what's going on. So when you hit the, hey, I want to simulate this button, that's actually what gets created in OneSAF. It looks exactly like the same topology or the same graphics, the symbology. And then it goes and executes the mission using those symbology. You can see the arrows and stuff. You tell it where to go and what to do. On the right-hand side, kind of at the bottom, I know it's kind of eclipsed by the other thing, but there's 9 pictures there. in the beginning we thought, let's hide it completely from the view of people. But people then they're scratching their head, they want to see something. So we're like, all right, we'll show you something, but you see 9 things executing at the same time. It may or may not make any sense, but at least it gives you a warm, fuzzy feeling of something's working in the background. So we show in CyberSAF symbology the 9 scenarios going on. It runs in like a cloud or however you want to run it. And it gives you results. And the results are summarized here by this graphic on the top of that. And the idea with that is to show of those courses of action, what has the best opportunity for saving blue 4 lives or saving ammunition. There's different objectives, and you get red, yellow, green on those, and it'll recommend a course of action that has the most green. And also, that does that on one axis. On the other axis, it's which is worse for the bad guys. So it helps guide you. And of course, if you question it, you can just adjust the scenario and run it again and see, if the simulator is right or wrong, or maybe your plan needs a little work. And on the top, it just shows a couple graphs that come out of that. This is probably a little too much detail, but I wanted to show it anyway. This is the architecture of how we plug it into CyberSAF. We designed it in a way that, we do OneSAF and MTWAS, but any other simulator can hook up to it as well. We're in the process of doing a third one now, actually. And that's essentially this diagram. So number 2, emulating an array of realistic mission-specific logical environments. So as we talked about, there are other simulators that interact with OneSAF or CyberSAF. Scalable networks, Network Defense Trainer is one. Carnegie Mellon, Step Forward. My understanding is CyberSense also does. OneSAF, so that's one way to do high-fidelity cyber. OneSAF actually can act as a low-fidelity cyber simulator as well, just with its own capabilities to do cell towers, IP networks, satellite links, new capabilities being developed right now for GPS jamming. OneSAF also, this is kind of a special case, but there were complaints, I guess, in the community that when they try to use traffic generators on tactical networks, it looks like a corporate network. It doesn't look like a mission command network. So they actually use OneSAF as a tactical traffic generator also to generate realistic-looking feeds. So OneSAF can be used for that. And OneSAF also has another component called cobwebs. And the idea there is you can insert it in between OneSAF and mission command systems to simulate attacks on those mission command systems without actually touching those mission command systems. So you can selectively take out feeds or make them look messed up on purpose when ideally the commander wouldn't notice or until maybe it was too late. So it tries to train them how to respond to those conditions. So OneSAF has inherent capabilities as well. So number 3, MNS is necessary for CyberSU. We're pretty happy to do this work with CyberSAF and OneSAF. We think it's pretty neat and pretty useful. Hopefully someone else does too. And as we said, we want it to operate quickly. By the time the commander has it, get a cup of coffee. And so far we're meeting that objective. It's pretty fast. And we're also challenging ourselves to not just do 9, but do thousands of runs. If we know, that's another thing we're looking into. Let's see. So I mentioned CyberSAF, I mentioned OneSAF with CyberSAF, but what we haven't done is actually done CyberSAF with CyberSAF, though in theory that's a configuration change, but it won't just work out of the box like that. And there's three ways we got to progress, but the first one is really the challenge for us. Is in the, to our knowledge, and maybe this is old information now, if someone knows, please let me know, but the 25B CD symbology doesn't support cybergraphics to our knowledge, or if it does, we're just not finding it, or we just need some help with that. So you can put your maneuver graphics and all that, but you can't, how do you represent the cyber effects to execute? So because we don't have those inputs to put on the mission command system, we can't then put it into OneSAF. So that's the challenge with just hooking the 2 things up here. So that's kind of where we are at this point. But once we have guidance on that, then it would just be pretty straightforward from that perspective. We'd have to get those commands into OneSAF. And then OneSAF would execute the mission like it normally does. And then we need to be able to get that data back into CyberSAF so it could display the graphs. So that's, from our perspective, this solution is state-of-the-art where we are. And then number 4, MNS synchronization. The topic talked about a couple different things here. OneSAF has an ability to interoperate with a lot of different systems, mission command systems, or other simulators. And there's various protocols. I only listed a couple, but there's a bunch. There were some questions about cross-domain solution. OneSAF, as I said, is a framework to build simulators, and you can use it. They use it on Warsim for that, and AFCEA uses OneSAF as a system also. And in those cases, they participate in exercises separated by a guard interface. And what we're saying here is, well, actually, that's the next point. But so essentially, the higher classified stuff is in a higher upper enclave, and lower classes in the lower enclave. Then there was a comment about, well, PCT, they want to, avoid too much traffic going over to cross-domain solution, essentially. So our suggestion to solve that problem is don't put all that traffic over the cross-domain solution. If you use this type of approach, like on-off compromised, you only send those messages up or down that you need to, and there's no details of the mission or anything like that of how the how was done, just the what. So that would save a lot of traffic going through the cross-domain solution, if that's an acceptable solution. So that's our perspective on that. And I don't know how I did on time, but hopefully oh, good, I did kind of perfect there. Good. So I have time for questions. Also, I printed some white papers if you want a soft copy, I'll be happy to email you. If you want information about OneSAF, the government points of contact, I can help with that too. Yeah, thanks. So, any questions? Thanks. Yeah. Mm-hmm. Mm-hmm.
Do you have an ATO?
Oh, yeah, once.
I'm sorry, let me redefine that question.
Yeah, yeah.
Do you have an active approved ATO, not an IDTO?
You know what? There is an answer to your question. It's a technicality because on OneSAF we don't field it. We hand over the software and somebody else goes and uses it. So the answer is we are RMF accredited at the end of each delivery. But I don't know the final answer of whether the organization who has OneSAF gets the ATO or we provide it. I'm sorry, I don't know the answer. That's a good question. I feel bad that I don't know the answer. But in general, it's not a hurdle. I mean, this has been done. I mean, any more than it normally is. Yeah.
You say giving an ATO is not
Yeah, well, and any more than it is. I wouldn't say it shouldn't stop you from wanting to get it because it's been done many, many times. Is what I meant to say. But yeah, it's obviously challenging to get. But OneSAF out of the box is designed to be, yeah.
trust me, I'm very familiar with that. So,
Yeah, sure, yeah.
the question is you're an add-on to a OneSAF environment, which means you're either going to come up underneath their ATO or you can have your own individual ATO.
Right.
So the question then becomes usability in classified environments.
Yes, so I should have said both CyberSAF and this capability for the course of action analysis. We developed that as IRAD and also cooperative development also. And that OneSAF has a co-development approach, so people can hand their code back to OneSAF program, and we have done that. So those capabilities are integrated in OneSAF. So that RMF machination is going on with this stuff. So it's just part of the natural evolution of this. Yeah, sure, thanks. Yeah. I feel bad I don't know the exact answer, but we definitely know people who do. Yeah. Sure. Any other questions? Yeah. Thanks.
Kevin Hofstrom with CyberSAF.
I saw you yesterday in the presentation.
With
Oh, yeah.
The CyberSAF API that you discussed,
Mm-hmm.
is that something that you're actively developing under the project?
My understanding is we're done. We're done for now. So I mean, could it be better or whatever? Sure, but yeah, it's usable. It's works with other simulators.
So it's in the OneSAF baseline, and there's a cyber harness, but there's not yet an API.
No. It's as far as I know, it's all there. Yeah, I mean, yeah, it's usable. Hopefully, there's documentation. If not, reach out to us and just help out. Yeah. Well, thanks. I appreciate the time and the questions. Switch. Yep.
Good morning. My name is Paul Davis. I'm from LGS Innovations. I'm here today to present some of our work in modeling and simulation, specifically live RAN. Live RAN is the modeling and simulation product that puts a commercial 4G wireless network in a box. It's a fully deliverable, functional LTE cellular network in a modular form that allows customers to both simulate and emulate real data calls, designed such that live and virtualized equipment can be swapped at will, which allows testing of all network entities, including both the RAN, EPC, using rigorous protocol layers and precise autonomy. That's a bit of a mouthful, but what does that really mean? We can start with, how does a cell phone work? We can start with, you're probably familiar with your user equipment. We would call that a cell phone or a mobile. It could also equally be tablet or any other LTE type device for IOT, etc. This is talking to a base station. In the literature, call it an E-node B. You've probably seen this on the side of a highway. It's broadcasting its existence, and the UE says, hey, I want to talk to you. And the E-node B says, here I am, let's talk. This sets up the UU channel. I won't go into the details of the protocol. It's rather complex and rather boring, but suffice it to say that a link is set up. Now, while this is occurring, the E-node B is pointing back to its manager, the MME over the S1 MME, and saying, hey, I got this guy who wants to talk to us. He says, okay, give me his credentials. And he hands that to his accountant over the S6A and says, is this guy for real? And he says, yes, he is. I'm going to give you his keys for confidential integrity. And immediately this sends that back to the UE to go secure. Meanwhile, the MME is contacting his buddy, the SGW over the S11, to set up that data connection. The SGW sits there and contacts his manager, the PGW, which has the internet connectivity over the S5, and says, hey, can we actually handle supporting this data call? And PGW says, yes, we can. The SGW then contacts back to the MME, saying to the E-node B, set up your S1U to make the data call occur. And this is all what happens when you come out of airplane mode and suddenly you get white bars. Just for nomenclature, so you understand, with the radio network and obviously the evolved packet core. What we've done for phase one was implement using live UEs, real carrier-grade E-node Bs and a COTS virtualization server, leveraging the Exada simulation and emulation framework from Scalable Network, and then started using well-tested libraries for protocols to handle the details down to the bit accurate level, allowing us to also support full crypto and the necessary control and state machines. We've also designed a web-based application to control multiple live devices we call Device Farm. And this allows us to handle both iPhones and Android devices, as well as digital variable attenuators and phase shifters so that we can simulate Ricean fading and all that. As well as we can script individually each of these devices in a clickable format through a web front end that allows us to then script and set up constructive scenarios. So we can start with that previous diagram and multiple UEs, which as I said, we control through this web front end. It allows you to swipe and click and do all the things that you want to be able to do as if you were standing directly in front of a live UE. Back. All right. So these are the live elements in this scenario. These are the virtual elements, which we're simulating the EPC. This is running, as I said, on the Exada framework on a COTS PC. This allows you to then talk to either a public or private network seamlessly. What I'd like to show you is a demo of this occurring, where we move out of airplane mode, start talking, you'll see Wireshark on the right-hand side showing the precise protocol as we're going, and basically the connection and we'll be surfing. So you can see on the left-hand side, as we move out of airplane mode, see some of the data traffic at the S1 AP in this case, on the Wireshark on the right-hand side. And you can easily search, click. This is all recordable, so you can go back and replay this information. It'll allow you to set it up as macros, so you can set it up to play things. In this case, you kind of recognize the site we're surfing to. And then you can also type, enter in for information. And this is not just for a web browser. This can be any application you want to be able to run on a live or virtual phone. And this isn't just slow speed simulation. We're doing stuff at speed. So this is real. And as we move back out of airplane mode, you can see, yep, there's the end of the call. There we go. All right. Currently, we're working on separating the control plane, the MIE HSS, from the data plane, SCW PGW, to allow interoperation with live XGWs for hardware-in-the-loop data traffic. We've enhanced our capabilities to support both S1 and X2 handover, as well as multiple APN support, so we can supply the ability to support multiple carriers independently. We also can support, starting to support virtual UEs and eNode Bs that have an Android environment running that allows you to run unmodified applications within the environment. These are, again, scriptable. We've also begun supporting private internet development, so we can select and scrape websites, email services, and start handling network services such as Signal as our first application on them. So again, we have live and virtual, which we're separating into the control and data plane with an S11 interface. This allows us to handle handover as well as virtual elements. These elements can talk, so you can talk live to live, virtual to virtual, or live to virtual, and it doesn't know it's talking to a dog on the internet. It's precisely what's going on. And again, we're supporting services. Said Signal is our first one, but there will be other ones as we go forward as interest is peaked. As well as this still obviously can still connect to the internet. And we validated our S11 interface by using a Nokia 7750 mobile gateway, so you know that it's accurate to the bit. The realization of our first is a 2-cabinet 42U Tempest enclosure that has on the left-hand side over 200 UEs. These are either tablets, iPhone, Android, or other modems, and possibly other devices of interest if you wish to be able to test those. On the right-hand side, the requisite telephony power supplies, routers, the VM server, and up to 4 eNode Bs of either. We can supply you with, currently are showing a Flexi Mini, which also supports carrier-grade Wi-Fi for 5G support, but right now we can also handle macro cells of both TDD, FDD, as well as microcells. In the future, we're looking to enhance this by adding to it scenario development so that we're not just handling the upper layers of an LTE network, but delving down into the IP and MPLS layers and including all the way down the optical transport domain. We're separating the SCW from the PGW, which starts allowing you to support multiple carriers and roaming, separating the HSS from MME, and adding PGW to MME initiated communications from mobile terminated calls. So what you're starting to see is something that looks like a carrier, full simulation. You can sit there only limited by the amount of computing power that you have. Again, we're separating out the MME from the HSS. We have plans to separate the SCW from the PGW and create the S5 interface, which allows you to create multiple SGWs, as well as supporting live SGWs. Similarly, supporting the S8 interface so that we can handle roaming across the foreign PGWs. So I'd also like to show you a scenario where we are using a virtual UE. And because Exada already supports the ability to simulate terrain and movement of network elements, we can start supplying complex scenario designs. What we'll see is a GPS simulation running unmodified Google Maps within a virtual instance of a Android device. So what you'll see here is a GIS map on the right-hand side of Augusta. And if you look very carefully, you'll see a UE traversing down Reynolds Street right out front here as it's communicating with a capricious eNode B sitting across the river. And on the left-hand side, you'll see the Google Maps showing you not only the communications that's occurring with network traffic being updated, but also we're simulating GPS coordination so that you can start doing testing of location-based applications. So what does it bring you at the end of the day? Numerous cyber ring modeling simulation needs with high fidelity. Obviously, you can start modeling network deployment and design with terrain effects, but you can only use this for small, few hundred users. You can actually deploy this in small fields. You can start doing network element testing and validation for network assurance applications because we control the protocol, so we can customize it for your needs. We can start handling similarly the mobile devices. If you want to be able to do testing without an FCC license and broadcasting on the large, you can test this in a localized environment, as well as application analysis, in case you want to be able to sit there and look at location-based services that morph example. Well, obviously, our 3GPP network protocol traffic analysis is intrinsic to the product and allows you to sit there and model precisely what is going on within it. What we're doing is not just modeled simulation of data traffic, but it's live. It's the real thing. And then you can repeat it time and time again, including hundreds of users working simultaneously, both in the live and the virtual. This allows us to start handling planning, mission, and proficiency training using 4G networks. We can start creating constructive event-triggered scenarios, and then help you develop situational analysis. So if you have to deal with some rapid disassembly of UEs or connections, either through the microwave or optic link, and be able to handle that with a rapid course of action analysis ahead of time. So, I'm Paul Davis. Is there any questions?
So the UE that you have in the web interface that you instrument
Mm-hmm.
controls a virtual machine?
There's both a virtual as well as live. We can, through a wired interface, we can control that through USB as distributed. I don't know if you remember on the diagram here, but we have a number of UEs stacked within or of all sorts, and the PC that controls them, as well as the variable attenuators. These are sectionable such that you can actually create separate sectors.
And the VM-based one, it's a full stack of Android and Apple, or
It's full it's the AVD implementation, so that gives you what's basically IP, TCP, UDP above at the application level. But then you have the whole RLC, RRC, PDCP, and other protocols at the packet level. Not quite going down to waveform yet, but it does allow you to sit there and look at that from a standpoint of understanding what's going on within the network on a per user basis. Any other questions?
Oh, this is very nice. I like it. Thanks. What are you guys doing above and beyond what I can get from freely available open modular frameworks like Core and UE?
So Core is pretty nice. It's a good start. Support for some of the crypto like Zuck, etc. Not there yet. Maybe it'll get there. Allows us to also sit there and work directly with Android virtual development, so that we can actually create and we can sit there and test within a QMU situation. So if you want to sit there and do analysis of a virtual UE, what's running on there, and understanding exactly what it's doing, we can do that. Some of the other abilities, as I said, to work with live equipment. CoreNet's pretty good for some of the simulation. I admire their work, but we validate our stuff against carrier-grade technologies. So you know that it's the real thing.
So on your RAN model that you showed earlier, there's a portion of this. In your model, do you have an API that I could inject electronic warfare?
That's part of the Exotic framework, and it actually allows you to sit there and cause packets dropped, ricing, fading, and other impairments, and that sort of thing that you want to be able to do to show how that would act before you even deploy. So if you're testing network equipment, or you're testing UEs, that sort of stuff, or even when you go to deploy, you should see exactly what you're seeing in simulation when you go.
So can I simulate my UEs? Do I have to have live apportionment, or can I completely simulate my UEs?
You can completely simulate the UEs down to the level of being able to sit there and run individual apps, different kinds, running simultaneously. So you can start creating scenarios. So if you have a whole field of users you're simulating going out and you want to play follow the leader and try and find someone in the middle of all that traffic, and start doing that. You bet. It's at the, we'll have this in a slick sheet over at their booth down the center of the exhibition hall. Anyone else? All right. Thank you very much.
I'm a little hurt. Morning, everyone. My name is Jason Crowley. I'm here representing Dexter Edwards. Prior to beginning, I'd like to take a moment to consider the ways that, or some of the ways that modern warfare has changed over the last couple hundred years. Right? Modern warfare has taken on a more tactically agile stance. It is more deceptive in nature. They employ more stealth, and where available, they employ disposable things. Drones would be a good example of this, in that you are utilizing a drone to take the place of a person, thus saving lives and additional assets and capabilities. However, this is not done in networking per se. Oftentimes, or every time you get on the internet, you are essentially at war. You see it in today's news. Our adversaries are looking to attack and infiltrate our cyber networks. Concurrent with that, there are cyber actors. There are companies that are attempting to collect your IP. There are nefarious actors attempting to steal your data, your money, your identities. And then there's nation states who are attempting to infiltrate or disrupt your operations. Why haven't we made any changes? Why haven't we moved forward in networking? Well, for one thing, networking is not easy. It's not easy to get right. It's time consuming. It costs money. And once we're done with it, we tend to want to remain done with it, right? Once we've got it up and running in a manner that we'd like, we tend to want to keep it that way. And so we resort to O&M practices, the implementation of firewalls to surround your network, the implementation of IDS or IPS, honeypots, DMZs, those things all designed to protect that network. However, that network still remains static. And the longer something is out there to be attacked, the better opportunity there is for an attack to be successful. A long time ago in a former life, I worked with locks. And we were always told that locks only keep honest people honest, and that bad guys, given enough time, will have the opportunity and will break that lock. The same applies to networks. But what if you could stand up a network on demand when you needed it in under an hour? What if that network existed only the time that you needed it, whether that be a day, a month, a week, a year? And what if once you were no longer in use, once it was no longer needed, you could burn it down, destroy it, leaving no trace that it ever existed? What if you could take advantage of the CSPs, the commercial service providers that exist currently, their global scale, and all the things that they do well? What if you could expand that globalization? What if you could extend that to your perimeter network, your perimeter personnel, using usually untrusted network systems, whether that be 3G, 4G, things of that nature? Well, Fognigma does that right now. Fognigma is a patented and proprietary software engine that allows you to do all of those things. It is TRL9. It is currently deployed in the DoD and the IC. It is currently overseas. It is currently utilizing commercial networks, untrusted networks, to provide these secure networks and the collaboration tools that I'll get to in a moment. So what does Fognigma provide you? It provides you the opportunity to make these mission partner networks. It provides you rapid globalization, utilizing those commercial cloud providers. It's on when you need it. This does several things that I'll discuss in a little bit. It's fully encrypted, end-to-end, dual-wrapped AES 256 encryption with a 4096-bit RSA initial key exchange. It's cross-platform, works on all your devices that you have on you right now. No need to purchase any additional devices. And it's burn after use, as I mentioned. Tear it down, it no longer exists. So what we've done is we've integrated into 7 commercial cloud providers and 2 private cloud providers, those being OpenStack and VMware. What this allows us to do, it allows us to utilize one, any, or all of those providers to create a network. That provides you access to over 150 data centers, spread out over 50 regions, and allows you to operate simultaneously in 5 continents. Again, it works over untrusted infrastructure. The map on the lower right-hand side of your screen as you look at it shows you the 3G and 4G cellular networks in the world. We operate on those utilizing the devices, again, that you have in your pocket. What is a Mission Partner Network? Quite simply stated, Mission Partner Network allows 2 organizations to communicate safely and securely. Today's multinational, multi-organizational partnerships, interoperability has become a problem. It will most likely remain a problem. This allows you to solve that problem and utilize components within the network to ensure safety of operations and operational security. So think of it as you have forces in Afghanistan operating with the ANA in Kabul. You don't want them to have your crypto. They're not going to get on SIPR anytime soon. This allows you to communicate with them securely. Implementation options. One thing that separates Fognigma from a lot of our market comparisons are the fact that it was never created to be a service. Fognigma was created to provide to the customer for them to implement on their own servers with their own cloud instances and utilized with their current personnel. You have full control of your data. You have full control of where that data goes. It never passes through Dexter, Edward, or any other companies. It is yours and continues to be yours. You can do this on premises. You can have virtualization into the cloud, or you can use a hybrid cloud, utilizing your own private infrastructure. We do this through a series of hardware and software capabilities. Hardware items such as the Wicket, which is a small office, home office device, SOHO device, that an individual can carry with them. They can connect that to any network where they're at and provide and have access to that network and the collaboration tools. Conversely, the gateways protect facilities in the same manner. Everyone leaving that facility will enter and exit through the MPN. And then for those customers that may come under a little more scrutiny when traveling, we provide commercial off-the-shelf devices that are flashed with Wicket software, which we call embedded Wickets. So you essentially have a COTS device that has a Wicket capability. The information on the Wicket is just a small amount of proprietary code pointing it in a certain direction, so if compromised, there is no compromise. Software, cross-platform applications. So we have application that allows you to sign in, authenticates you to the network, and allows you to use the network. Again, this takes advantage of the devices you currently have in your pocket, the devices you already have on you, and mitigates the expenditures that you would have with a lot of implementation of other devices. Okay? Well, sometimes you don't want to have that either, because that will bring some scrutiny if you're going through the airport and somebody looks at your phone. All right? We offer portal proxies. A portal proxy is a unique URL fitting an individual's pattern of life that allows them access to this network. So an individual can utilize this URL to access the network, the collaboration tools therein, without drawing any specific or any additional scrutiny when passing through areas. Within the cloud, or within the network, we have a series of components. Video conferencing, have meetings, conduct training, build rapport with an asset, build rapport with your partners, all through what you would essentially assume to be, FaceTime-like capabilities. Okay, virtual desktops. In our environment, you are able to build and create and utilize sandbox virtual desktops. These desktops are Windows-based or Linux-based. They provide you all the actions and applications that you are familiar with. They have USB enabled so that you can still utilize CAT cards, scanners, printers, things of that nature. They are, as I mentioned, sandboxed from the host environment. However, you still have access to place things on the home environment if you're, say, doing OSINT and you capture some data that you want to bring out and put on an alternate system. It has dynamic exit points, so you can have an individual operating out of Augusta, Georgia, seeming as though they're surfing the web in Thailand. Concurrent to that, our VDIs utilize the local DNS as well as the time date stamps in those countries, so that, which are normally potential indicators as to you utilizing a virtual machine or a VPN or something to that effect. You can also utilize this for cyber warfare in terms of pen testing or SQL injection attempts, while all the while protecting your home network. And then there's the integration of capabilities. So any organizational or required components that you need on these desktops, they can be integrated. No one calls anymore. I personally don't. I try never to. Utilize messaging. So this provides you a secure messaging application that allows you to trade information, documents, PDFs, videos, and the like, while simultaneously giving you real-time communications in a format that is most used today. File sharing. This allows you to host, store, share, collaborate on specific files. You can post SOPs, continuity books, exchange information with partners, all in the safety and security of that MPN. Automate it. Automate all of it. If your personnel only work 12-hour shifts, they work from 7 to 7, bring up the network before they get in, burn it immediately after they leave. The duration of time that the network is available for attack lends itself to attack inherently. If it is not there, it can't be attacked. So you simply create a new network every day for those people. They get new IP addresses. They have new exit points, all automated based on stockpile. Reverb is our telephony app. So this is secure end-to-end encrypted voice. Again, it's dual-wrapped AES-256. However, this isn't desk-to-desk, although it can be. This is phone-to-phone. These are the devices you currently have in your pocket. Utilizing applications or URLs, you get into the network, you utilize a commercial open-source application, and then you're able to communicate securely with others over the device you already have. Concurrent to that, if you need some obfuscation, say you are a humanter, or you have a contact or a developmental source in an alternate country, we can utilize call chains to disassociate two entities or multiple entities. Essentially, we utilize SIP lines for that. So your asset in, say, Thailand could call a SIP line based in Thailand. That gets routed through an alternate SIP or passed through an alternate SIP that is here in Augusta, which calls you. The phone records appear as though you've never called anybody outside of Augusta. They appear as though they've never called anybody outside of Thailand. It limits their exposure. Are we safe? We white box test every quarter through a third party. We black box test almost every quarter through a third party. We believe in the capability. We utilize it for our work functions. Many of us utilize it at home, and we hope you do too. Again, my name is Jason Crowley. Do you have any questions? Excellent, thank you.
done it here?
Crowley. I came in to snap a picture of them. They're done. So I'm guessing I didn't show that.
I had all three. I do know that because they came. We had two that came in, and then Cindy gave me the third one. So
So you
should
have
have.
one for on-demand, secure, and traceless cloud networks?
What was his name?
His name is Jason Crowley.
Jason. John.
Well, yeah, if you want to stop by sometime, Untitled is more than anything else after you.
No, that was the second one.
So we're in the exhibit right across from you.
Yeah, so I'm guessing that was...
That was one for this morning.
Oh, there he is. Okay,
Yep.
so I guess he was here and he was done